In this session, we will go through the introduction to Docker. If you are a developer or a tester, you might have come across this situation. So let us assume that if you are a developer for time being and you have your own environment set up to develop that application on your local machine. Okay, and now you have the application developed and you are ready to deploy that into SIT environment. Okay, now once you deploy the same application which was working in development environment might behave differently in SIT environment. Everybody has come across this particular situation. Or if it is working on SIT, once it is deployed into production environment, it could behave differently. It is because of different environments you might have on SIT and production as compared to development, or you might have not set up the environment correctly on SIT or production. Maybe some of the dependencies were not set up correctly on SIT or production, or some of the dependencies versions may be different. You might spend a lot of time in comparing the SIT and development environment. So it could be lack of dependencies or different versions of the dependencies you might be using. So this particular set of deployments from dev to SIT to production, so you have to have the same kind of environment set up on all the machines, be it SIT, be it production and development. So you need to have the same environment set up as your development environment. Okay, first thing is setting up is not easy. It is time consuming, and also the dependencies may vary. Suppose say if you are testing this application, if you are testing it in SIT and SIT is absolutely fine, and then if you started testing it on production, you start finding issues which were not there in SIT. So again, that needs to be investigated. Most of the time it will be due to the environment difference or the dependencies. You might have also come across some applications which you download from the internet. It might work on your machine, it might not work on your friend's machine because of various factors. We have this standard issue. How do we resolve this issue? Okay, how do we make this environment a standard environment? That is where the Docker comes into picture. To see what Docker is, let us go to docker.com, and here you can see, so Docker is a container. A container is a set of things which are grouped together into one particular container. So you might have seen the ship container, wherein the container might have a variety of things in it bundled together. Okay, so in terms of Docker container, it's a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably. So in our case, whenever we move from development to SIT, we found that in some cases it is not very reliable. Right? So Docker solves that particular issue. It runs quickly and reliably from one computing environment to another environment. So it is not environment specific anymore. So it can run on any environment. Okay. A Docker container image is a lightweight standalone executable package of a software that includes everything needed to run an application code, runtime, system tools, system libraries, and settings. So what this Docker does is, so whatever you have in the development environment, so that can be made as an image, and the same image can be distributed to your SIT environment and production environment. So once you have the common environment with a common set of application code, a runtime environment, and system tools and system libraries and settings, then you will solve the problem of running on my development environment and not running on SIT or production environment, because you will be deploying the same container image which contains all these set on SIT and production. The application which works on dev now will also guaranteed to run on SIT and production. If you want to run the Docker, so you need to have a Docker engine. Okay, so if you look at this diagram here, you will have this infrastructure, which is a hardware. On top of the hardware, there are different types of hardwares available to run your operating system. Over this hardware infrastructure, so you have this host operating system, which can be Windows, Mac, Unix, Linux. Okay, and on top of this host operating system, Docker engine sits. So this Docker engine ensures that it interacts with this host operating system and eventually the infrastructure part. Over this Docker engine, you can have many containers or images. We will see what is the difference between container and image later on. So you can have different containers which contains different applications. So this container contains application A, application B, application C, application D, application E, and application F. So these are different applications which are run on this particular Docker engine. The Docker containers which runs on this Docker engine are standard, and it is lightweight, and it is secure. That is the end of this session. Thanks for watching. Please stand by for next video. In today's session, we will take a look at the difference between containers and virtual machines. So you might have used virtual machines in the past. We want to look at what is the difference between virtual machine and a container. Okay, again going back to the docker.com documentation, let us look at this picture now. So on the left hand side we have a containerized application. On the right hand side we have virtual machines. So if you look at the bottom layer, infrastructure remains the same in both virtual machine as well as Dockers. In Docker, the Docker engine sits on top of the host operating system, wherein in virtual machine, as you can see, it sits as a guest operating system. Okay, so each virtual machine will have its own guest operating system, wherein in Dockerized applications, the host operating remains same, wherein in virtual machine, there is something called guest operating system, and these virtual machines deals with the infrastructure by using a software called hypervisor. This hypervisor will interact with individual virtual machines which is sitting on top of the actual infrastructure which hosts its own operating system. So if you want to have application A in virtual machine, so you need to have a guest operating system, wherein in Dockerized platform, you have application A which interacts with the Docker engine. In turn, it will interact with the host operating system. There is only one host operating system, wherein here in virtual machine, it will have its own guest operating system for each of the application. So that makes this Docker a lightweight application compared to this virtual machine. And also the booting time which is needed for virtual machine is far more compared to your Docker container. Okay, it takes a lot of time to boot up in virtual machine environment, wherein Docker boots up very quickly. Since each virtual machine contains a guest operating system, it is not a lightweight application, wherein the containerized applications are lightweight. It doesn't take that much memory. The application hosted on this particular virtual machine, it takes time to boot up because the operating system has to boot up. Only when the operating system is up, the application will start running. And the boot up time is more, as well as the memory consumed by the applications which is running on these virtual machines is more compared to a Docker containers. Okay, the Docker containers will boot up quickly, and also the memory taken by each of these containers is really small. So if you go up a bit, the Docker container technology was launched in 2013 and it has picked up the pace in recent years, and now Docker containers are everywhere. So you can find Docker containers for Linux, Windows, cloud services, and most of the data center now use Dockers or Docker containers in day-to-day operations, and it is also an open source project. So we saw the advantages and disadvantages, or the difference between container and virtual machine. So does that mean that we get rid of all the virtual machines? No, we can still run different applications on these virtual machines. And the combination of virtual machines along with containers can also be used. As it says, the containers and VMs used together provide a great deal of flexibility in deploying and managing application. That is the end of this session. Thanks for watching. Please stand by for the next video. In today's session, we will take a look at how to install and set up Docker on Windows machine. As we have seen in the earlier video, for Docker to run, we need to have Docker engine installed. Go to docker.com and products and container runtime. And there are two types of Docker engines available. One is enterprise, which needs to be paid, and there is a community version. Download the community version. Click on download Docker engine, and that will take you to the Docker Hub. And from this Docker Hub, you can select which operating system you are on. So now I have this Docker desktop for Windows. So I select that. You need to have an account here. So I will log into my account here. After logging in, you will get this link to get the Docker. And click on the link to get the Docker. And I will put it into desktop. While it is downloading, I'm going to pause the video. The download has finished. So let us double click on it. Click on yes. Okay, click OK. As you can see, the installation was straightforward and it says installation succeeded. Let's close this. After the installation is successful, you need to go to where you have installed the Docker, okay, and start this app. So it should say Docker desktop is starting. As you can see, it is starting up. Okay, now it says Docker desktop is now up and running. Okay, open your favorite terminal and start typing Docker commands. Okay, and click on OK. Okay, now let us open up a command prompt and type in Docker info. So if you get the information about the Docker, that means your Docker installation is successful on your machine. Before you try out any of the commands, you should ensure that this Docker desktop is running. If not, you need to go to search bar and search for Docker and click on Docker desktop and wait for it to start running. That is the end of this session. Thanks for watching. Please stand by for more videos on this channel. See you in the next video. In this session, we are going to take a look at the basic commands used with Docker. Before we start looking at the basic commands, we need to understand the difference between an image and a container. That is, a Docker image and a Docker container. Okay, so what is a Docker image? So this is an image which has got these different layers. Let us say A, B, C. Okay, so this is a set of layers which are created and bundled together to create this particular image. Okay, and once we have created this image, then we cannot modify this particular image. However, we can delete the image and recreate a new image, or we create an instance of this particular image, modify it and store it as another image. Once this particular image is created, we cannot modify it. Okay, so when I say I cannot modify it, let us assume that I wanted to add another layer here called D to this particular image. I cannot do that. However, I can create a container based out of this particular image which has got A, B, and C already, so which is exactly similar to this image, but now I can add a D to it and create a new image which is image 1. However, this image remains the same. So if you pull this particular image, it will still contain only A, B and C. However, the new image, image 1, will contain these basic layers, which is A, B, C, which is contained in image, and the new layer which is added as D. Okay, so once the image is created, then you cannot modify it. However, you can delete it. Okay, so that is about image. So what is a container? A container is a running instance of this particular image. However, okay, so this container is Let us say I have created a container based on this particular image, which is called image. So this will contain all our layers A, B, and C. So this is a running instance of this particular image. However, if I create a running instance of image 1, it will contain A, B, C, D layers. Now this particular container can be changed. We can add additional layer to it. Okay, as I said in image 1. So after creating the container, we can add additional layer to it and save it as a different image. So in our case, we stored it as image 1. So without creating an instance, we cannot change the image content. Okay. So however, after changing the image content, if we still pull this particular image, then it will still have A, B, C. However, the new image will have the additional layers which you have added. So that is why it is immutable. That means it is bound to have the same layers no matter where you install it or where you pull it. Container is an instance of image running on that particular machine. So however, the contents of container can be changed and saved as a new image. Hopefully it is clear the difference between an image and a container. Okay, so when I said images, okay, where are these images stored? If you go to hub.docker.com and after logging in, you can click on explore. This is where all the images are stored. This is a kind of repository where all the images are stored. So as on today, there are these many images available. You can also create your own image and add it here. You can see all the images which are verified and official images, and those images are categorized based on these categories. So you can start looking at the one which is useful for you. Today what I'm going to take a look at is this Ubuntu image. These are some of the basic commands which we will go through today. Some of them are image related and some of them are container related. So let us look at the image related. As we have seen, all the images are stored in a repository called hub.docker.com. So what we are going to do is we are going to pull an image called Ubuntu onto this particular machine. To pull that image, we are going to make use of docker pull command. So docker pull Ubuntu. Okay, so this will fetch the latest version of the Ubuntu image. This will fetch the latest Ubuntu image from hub.docker.com. So if you are using a proxy, you need to set the proxy so that it talks to hub.docker.com so that it pulls the image correctly. The next command is, since we have pulled the Docker image called Ubuntu, I want to see whether that image exists on my machine or not. So for that, I'm going to make use of Docker images. Okay, as you can see, it has pulled the image called Ubuntu. Okay, so this is the image and this is the image ID and this is the size of that particular image. This image is really small compared to the virtual PC image. Okay, so the next thing is Docker inspect. So what Docker inspect will do is it will go and inspect the image which we have downloaded. Let us see that now. Docker inspect Ubuntu, which is our image name. So this will give you the details of that particular image. Okay, so it has got an ID. If you look at further down, then you might also see these are the environment paths which is set inside this particular image. And also you can see, since we were talking about different layers, you can see these are the layers which are embedded into this particular image. And you can also see the OS, which is Linux here, and the architecture, which is AMD 64. So these are all the information related to that particular image. Okay, the next command is Docker history. And Ubuntu. Okay, so this will provide the history of that particular image. So this was the first part, and this is the next part which was added, and this is the next part which was added. So it will give you the history of that particular image. Suppose say if I want to remove this particular image, then I can do that by using docker rmi command. Docker remove image Ubuntu. Okay, now you can see that this particular image has been removed. Now if I look at Docker images, I shouldn't see any image here. So that image has been removed now. Okay, so these are some of the basic commands for Docker images. Okay, so let me pull that image back. Okay, so now we have that image back again. So now we will look at the container related Docker commands. So now we have an image. If you look at this particular image, then this contains, these are the layers which are contained in that particular image. An instance gets created which is called a container. Now we will run the container by using docker run Ubuntu. Okay, what this will do is this will run an instance of image called Ubuntu. So how do we see whether this particular container has run or not? So for that we use docker container ls. Okay, as of now you can see that there is nothing displayed here, but if I do all, then you can see this particular container was created and then it ran and it exited. Okay, so 33 seconds ago. Suppose say if I want to rerun this particular container, now this particular container has got an ID, okay, which is this. Now if I want to rerun this container, what I can do is docker start and the container ID. Okay, now again docker container ls. Okay, there's nothing running now. Now if I look at all, it should say now this container was started again a minute ago, and so this was created about a minute ago, but it the status is exited 15 seconds ago. So that means if you look at this one, it says 31 seconds ago and this says 15 seconds ago. So that means it started the container again. This is the existing container. So the difference between Docker run and Docker start is Docker run will create an instance of the image and runs it, wherein Docker start will start an existing container. Docker run will create a new container and runs it. However, Docker start will start the existing container. It won't create a new container. Okay, so that is the difference between Docker run and Docker start. Okay, so we have seen Docker start, Docker run, and Docker container ls. So another thing is we can use, instead of Docker container ls, Docker ps, which is same as Docker container ls, and we can also specify option called all, which will display the same information. Okay, the next command is Docker rename. I have removed all the Docker containers. Let me run the Docker container again. Okay, as you can see that there is a name. Okay, so this is the container ID and this is the image, this is the command, and what time this particular container was created and what is the current status, and this is the port number, and there's a name. The name says recursing McClintock. Right. So if you want to rename that name, then what we can do is Docker rename, and let's provide the ID here, and I will call it as Docker demo. Okay, so now if I look at Docker container PSOL, now instead of recursing McClintock, the name has been changed to Docker demo. So you can also rename the name of the container. The next command is Docker stop. Since we know that whenever we run Docker start or Docker run, it will run and it will exit immediately. So to show you how Docker stop works, so I have to go into interactive mode. For that I will use Docker run -i, which is interactive, and provide me a terminal like TTY terminal, wherein I can put in the command, and the image name is Ubuntu, and provide me the bash terminal. Okay, now this is providing me an interactive TTY wherein I can run the commands, for example ls. Okay, so now this is running in the background. So if I open up another command prompt and Docker container ps-all, if you look at this current status, it is up 28 seconds ago. Now it is still not, it has not exited yet. So what we can do is we can run the stop command to stop the other container. Docker stop, and this is the container ID. Okay, as soon as I type in this, you can see it sends an exit command to the interactive terminal which was open. So now you can see that that particular container has exited. If you are running, or if If the Docker container is running in background or in interactive mode, then you can stop the container by using this stop command. Okay, the next one is Docker restart. So Docker restart and provide the container ID. So what it will do is it will restart the container and then again it will exit. Okay, so now if I want to remove this particular, let me close the other window. Okay, so if I want to remove this particular container, then I can do that by using Docker remove and the container ID. Okay, Docker container ps minus all. Okay, as you can see, it has removed this particular container. Now because of the other run, Docker run, we have another container here. So let us kill this one as well, or remove this one. Docker container remove and the, so if I do Docker container ps minus all, then I shouldn't get anything. Okay, so now this is how we can use Docker remove to remove a particular container with the ID or a name. Okay, so we have seen this particular command, Docker run minus IT ubuntu bash. So this is one of the important command which we will be using in the next few sessions in order to create a new image. So these are some of the Docker basic commands, and we also saw how to make use of the Docker run command with interactive mode. So this we are going to use it in the next session to create our own image. That's all we have in this session. Thanks for watching. In today's session, we are going to take a look at bind mount and volumes. Before we take a look at what is a bind mount and what is a volume, we need to understand why do we need bind mount and volumes. By default, the files created in a container are stored in a writable container layer. And when the container doesn't exist, the data will be lost. Suppose say if you have a container running and you have created a file on a container, once the container is stopped, then that particular file will be lost. So there is no persistence available within the container. So that means the data doesn't persist on the container. Once it is quit, the data will be lost. In order to persist the data, so what is the other alternative? The other alternative is to have that particular data on the host machine. Okay, so Docker has got two options for containers to store files in the host machine so that the files are persisted even after the container stops. There are two ways of storing the files on the host machine and binding it to the container. The first one is using bind mounts and the second one is using volumes. Okay, there is a subtle difference between the bind mount and volume, wherein the bind mounts can be located anywhere on the host machine, and the files which are created within that particular host system can also be modified by the other processes other than the Docker processes. So that means Docker doesn't have control over the files which are on bind mount. The other way is volumes. Volumes are directly managed by the Docker. So non-Docker process cannot modify the file within this volumes. And out of these two, which one is the best way to have the data shared between the container and the host system? The one which is recommended is the volumes. First, we will try to see this particular statement wherein it says by default the files created on the container are stored in a writable container layer, and when the container doesn't exist, the data will be lost. Okay, for that what I'm going to do is going to see. So currently I don't have any Docker image. So what I'm going to do is I'm going to pull Docker pull Ubuntu. So this is the image which I'm going to pull it from hub.docker.com. And it is fetching the Ubuntu image from the hub.docker.com. Okay, now the pull is complete. Now we have Ubuntu image which is downloaded. So we will try to create a container out of Ubuntu image. For that, docker run -it, which is interactive TTY, and the image name. And by default, it is going to run this bash command. Okay, so let us do an ls. Right now you don't see any file here. What I'm going to do is I'm going to create this file called test.txt. Okay, for that I'm going to use echo hello and move this to test.txt. Okay, so now we have this test.txt created here, and let's go and see the content of that by using cat command. Okay, so now we have hello in that. Okay, so since the container is running now, so I'll open another PowerShell. So docker container ls. As you can see, up about a minute. Okay, so this container is still running, which is this container. If you see the container ID here, and this is the container ID. Okay, so let me close this. Now if I exit this, then the container should stop. Okay, so let us do docker container ls. Okay, there's no container running anymore. Okay, so now what I will do is I will go back and recreate this container by using the command docker run. Now if I do ls, that test.txt file which we created earlier is gone. So that means the data doesn't persist on the container. Once the container is stopped, then the data will be lost. So we lost this test.txt file. Okay, now we have seen that once the container is stopped, the data will be lost. Okay, the other way of now we will see the two ways of persisting data on the host system. First, we will take a look at bind mounts. Okay, let me exit this. For bind mount, what I have done is I have created a folder called docker under D drive, and currently it is empty. I'm going to make use of this particular command. Let me explain this command. So it is a docker run -it, which is interactive TTY, and the name of the container will be bind_mount. So you can give any name here, and the mount type is bind, okay, which is followed by --mount, and we need to specify the source and target folders. So the source folder which I'm going to use is d:\docker which I have created just now on my host system, and the target will be app folder. If the target folder doesn't exist, which is /app, then it's going to create the target folder on the container. Okay, and this is the image name. Okay, so let me start this. Okay, so if I do ls now, you can see that this is the new folder which got created, okay, which is the target one, which is /app on the container. So if I go to app folder and do an ls, so there is nothing currently in the app folder. Let me create a text file. Okay, so I'm going to make use of echo hello and then move this string to test.text. Okay, so now we can see there is one file which is test.text. Okay, so let us see the content of this test.text. Okay, it's hello. If I go back to my host system and go to Docker, you can see that the same file is available here, okay, which we have created just now, and it contains hello. So now this particular test.text file is shared between the container and host system. The disadvantage of this is since this test.text is not managed, other processes which are running on the host machine can also edit this. So for example, I'm editing it now, so I'm going to add world to this. Okay, so let me save this. Okay, now the same thing will be reflected here, cat test.text, even though I didn't edit it from this container. Okay, so that is the disadvantage of using this bind mount. Okay, so let me exit this. Okay, now the container is not running anymore. Docker container ls. So the container is not running anymore. However, we still have the file which is persisting on the host system. That means it still exists with the same content. Okay, so this is one way of binding host to the container or sharing the data between the container and the host. Okay, so let us take a look at the second way of sharing the data between the container and the host by using volumes. Okay, so let me clear screen here. Now if you type in command called docker volume and --help, the bind mount doesn't contain its own set of commands. However, docker volume has got its own set of commands. The set of commands include create, inspect, list volumes, and remove all unused local volumes, and remove one or more volumes. So create, inspect, ls, prune, and rm are the commands belonging to docker volumes. Before we use the docker volume, so we need to create a volume on the host machine. Docker volume create. So this is the command which I'm using, and the name of the docker volume will be test volume. Okay, now let me list the volumes. Docker volume ls. So let us inspect this docker volume. Docker inspect test volume. Okay, what this inspect says is the name of the volume is test volume and the scope is local, and it has created at this place var lib docker volumes test volume and underscore data. So this is created at this point of time, and then the driver is local. So this is the mount point which is directly managed by the Docker. Only the Docker process can modify the data within the volumes. None of the other processes like host processes can modify this particular volume because it is not available for other processes. Okay, let me clear the screen again. Okay, now I'm going to make use of this particular command, which is start the container by using docker run command, and start an interactive TTY, and the name of the container is bind volume, and this is going to be mounting the volume. Here earlier we had given type as bind for bind mount, and we have not given any type here. However, we have source and target. Source is the test volume, and this is the volume which we have created just now, and the target is mapped to /app folder on the container, and this is the image name. So let me start this. Okay, so again let us go to app folder because that is the mapped folder. Again we will create a test.txt file. Test.txt file. Okay, now let us see the content. Let us see the content of this particular file. Let me stop the container by typing exit, and now docker container ls. This container is not running anymore. However, we still have docker volume which we have created, okay, which is called test volume, and now this particular test.txt resides in this particular volume. Let me go back and create another container, and since we already have this bind volume, I'm going to create another which is bind underscore volume 1 and hit enter. Okay, let me go to app folder. Now since this is stored in the test volume, we had one file called test.txt, which is now we had one file called test.txt which is also available with the another container. Okay, so as long as the container is mapped to this particular volume, all the files which are available in that particular volume is shared across multiple containers. Okay, so let me do cat test.txt. Okay, so let me add another clue, and I'm going to add world from container to, and append this to test.txt. Okay, cat test.txt. So now what I have is here hello and world from container 2. Now if I exit this container, I want to delete the two containers which I have created, which is bound to this particular test volume, and they are named with bind underscore volume and bind underscore volume 1. Okay, so let me check docker ps container ls. Okay, so none of the containers are running. Docker container remove bind underscore volume, okay, and volume 1. Okay, so now we don't have any containers with that particular name. So since I don't have this, I'm going to create again bind volume, okay, which is the same command as this one here, okay, which is attached to test volume. Now this is a new container, if you can see. So this was the container ID earlier, and this is the new container ID. Now let me go back to app and cat test.text file. Okay, so here you can see that even though this particular text was added with a different container and hello was added with a different container, both of them are available to the new container. That means the data is persisted on the host machine and it has updated this particular file. If you want to share the data across multiple containers, volume or Docker volume is the best way to share it. Okay, so let me exit this, clear screen. Let me try to add the same container name again. It should give me an error. Okay, here it says the container name bind volume is already in use by container. That is the reason I had removed the container. If you go back to Docker volume help, we do have something called prune and remove. So you need to be very careful by before using a Docker prune or a remove command, because there might be a lot of data within the volumes. Once you remove the volumes, all the data within those volumes will be lost. So you need to be careful. These are the two ways of sharing the data between the host and the container and data persistence on the host system. Now let us take a look at what are the differences between bind mount and volumes. Okay, bind mount files or folders is mounted into container and depends on the directory structure of the host system. Since bind mount depends on the directory structure on the host system and we are mapping that particular host system directory structure into the container, if you want to take a backup, it is the host directory structure which we need to take a backup. Okay, so we can use --mount syntax containing key value pair. So as we have seen, the key value pairs are the source with the source folder name and the destination with the destination folder name, and the type is bind. Okay, so that is the key value pair. The file or directory does not need to exist on the Docker host already. So as I said, we were binding it to /app folder. It need not exist there. It can create on its own. Okay, once we use Docker run command, it will create that particular folder for us. Using bind mount, I can go to that particular folder and modify that particular file. Okay, so that means any other process can have access to this particular file and modify it without the knowledge of Docker. That means Docker is not directly managing that particular file. Okay, however, if you look at the volumes, okay, and this is again a mechanism to persist the data. Okay, you can also use -v or minus volume, okay, separated by colon. Okay, so let me talk about this --mount and --volume here. Okay, so by using --mount or --volume, we can also do a bind mount or a volume mapping. Okay, both can be used. However, In our case, I have used hyphen hyphen mount by providing the type. Okay. We can also use hyphen v or hyphen hyphen volume. So in mount case, it is key value pair. However, if you use hyphen hyphen volume, it is separated by colon. I will show an example later on how to use this particular switch, which is hyphen hyphen volume. It creates a volume on the local system. Volumes are completely managed by Docker. So that means any other process other than the Docker process will not have access to these files. As I have said earlier, the backup and restore of volumes is easy, but in bind mount it is the host system backup and restore. So you have to have the same directory structure. In case of bind mount, for volumes the backup can be taken and easily restored in the same structure. The volumes are platform agnostic. So that means the folder structure, whatever is created, whether it is Linux or Windows, it works seamlessly upon restore. Wherein with the bind mount, you need to know the directory structure for Linux as well as Windows. Since the directory structure varies from Linux to Windows, so you need to have the same directory structure. The Docker provides separate set of commands for volumes, which we have talked about earlier. As I said earlier, we can also use hyphen v or hyphen hyphen volume option within the Docker run. Let us see how that works. Okay, so this is the command, which is docker run hyphen it, which is interactive TTY, and the name is bind mount underscore v. Since we have used bind mount earlier, I cannot use the same name unless I remove that particular container. Since I have not removed, so I have used underscore v here, and this is the option which I was talking about, hyphen v or hyphen hyphen volume. This is the source folder, which is d:/docker, and this is the destination folder, and they are separated by colon and the image name. The main difference between mount and hyphen v is, or hyphen hyphen volume is, d:/docker should be available before binding in case of mount. However, if this particular directory doesn't exist, when we use hyphen hyphen volume or hyphen v, it creates this particular folder if it doesn't exist before mapping it. That is the difference. Okay, the command which I'm going to use here is docker run hyphen it for interactive TTY, and the name will be bind underscore mount underscore v. Since I didn't delete the container or remove the container with the name bind underscore mount, it still exists. So I have added underscore v to create a new container. Okay, so this is the new option. Instead of mount, I am using hyphen v, and here I have provided d:/docker, which is the existing folder. Okay, and followed by colon here and the destination folder. So this is the source folder, d:/docker is the source folder, and app is the destination folder. The source and the destination is separated by a colon, and the image name, which is Ubuntu. So I'm going to remove bash here. Okay, by default it's going to open up a bash shell. Okay, so let me do an ls, go to app, ls. So if I do cat test.txt, okay, hello world. So this is the text file which is under d:/docker. The only difference between hyphen v or hyphen hyphen volume and hyphen hyphen mount is, if the source folder doesn't exist, then by providing hyphen v or hyphen hyphen volume, it creates this particular folder on the host system. However, for mount, this particular folder, which is Docker folder, must exist before we bind it. Okay, so that is the difference. Okay, so let me exit this. Okay, let me try to inspect this particular bind mount underscore v. For that, docker inspect bind underscore mount underscore v. So if you look at this, under mount section, you can see these are the attributes. The type is bind here, which is exactly similar to our bind mount. And the source is host mnt d docker and destination is app folder. As we can see, hyphen mount is exactly similar to -v. In -v, the source and the destination is separated by a colon. Okay, so let us see the second way. Let me clear the screen. Okay, let us see the second way of binding it using the volumes. Okay, for that I'm going to make use of this particular command, which is again docker run -it, and the name of the container is bind underscore volume underscore v, and here instead of -mount I have used -v, and this is the source, which is the test volume which we have created earlier, and this is the destination folder, which is /app, and they are separated by a colon, and Ubuntu is the image name. So let me hit enter. Okay, so if I go to /app, again cat test.text. So this contains hello world from container 2. Okay, so this is exactly similar to -mount command, but using switch -v. Let me exit this. Let me do docker inspect bind underscore volume underscore v. Now if you go back to mount section here, the attributes are here, the type is volume and the name is test volume, and this is the source directory and this is the destination directory. Okay, so these are the two ways of sharing the data between container and the host system. I hope it is clear. If not, please provide your valuable comment under the comment section under this particular video so that I can respond to your comments. Thanks for watching. Stand by for the next video. In today's session, we're going to take a look at how to create your own image. In the earlier session, we have seen how to make use of the existing image which we have downloaded from hub.docker.com. In today's session, we will create our own image and upload it to hub.docker.com. The image which we are trying to create today is Robot Selenium framework image. Okay, so there are few steps to be followed. To create our own image, we need to have a base image. Since we have downloaded Ubuntu image earlier, we are going to use that as a base image. Let us go back to our PowerShell. Let us do docker images. Now we have Ubuntu image. The first step is we need to make use of docker pull command to download the Ubuntu image. Since we have already downloaded that image, so we are going to make use of this particular image by skipping step 1. The step 2 is we need to run a container using this image by making use of docker run -it ubuntu bash command. Okay, Okay, now we have a running container based on Ubuntu image. Before that, I wanted to show you something. Let me exit this first. If I do docker history Ubuntu, this gives you the history of this particular image. Okay, and if I do docker inspect, and if you look at the layers attribute, so it has got 4 layers built into it as of now. Okay, so let us go back to our step 2, which is docker run -it Ubuntu and bash command. Ubuntu bash command. Okay, so now the container is running, and within this container we need to add the packages. The first step is we need to update the existing packages. For that, we're going to make use of apt-get update Okay, so this will update the existing packages within this container. By using apt-get update, all the packages got updated now. Okay, the next step is we need to install Python. So for that, apt install Python 3.7. So this is the specific version which we are installing, which is 3.7. Instead of apt-get, we can also use apt. Okay, so yes here, 3.7. Okay, so it has installed Python 3.7. So let us see whether it is installed or not. Okay, Python 3.7 -v. Okay, so now this is the command to verify whether Python has been installed or not. So this is giving me the version as Python 3.7.5. Okay, so as a next step, we need to install PIP. PIP is needed to install robot framework. So first we need to install Python 3 PIP. I will provide all these commands in the description of this video. Let me pause the video and come back after PIP is installed. After some time, all the packages related to PIP got installed. Let us go back and verify whether PIP is installed correctly or not. So we can try out PIP3 command. If we get the help when we type in PIP3 command, that means our PIP installation is correct. Okay, the next step is to install a robot framework using PIP, which we have installed just now. Okay, so the command is pip3 install robot framework. Okay, so once this robot framework is installed, let us type in a robot to see whether this is installed successfully. After each step, you need to verify whether that particular package got installed or not. Okay, so I typed in robot there and it was expecting one more argument there. So that means our robot framework is installed correctly. Okay, as a last step, in my case, I'm going to install a robot framework Selenium library. Okay, now all our installation is done on this particular container. If I exit the container now, then all my installation will be lost. So what I'm going to do is I'm going to open up another PowerShell. Okay, so now I have two PowerShell windows. Okay, one where we have installed all the necessary items to build an image, and the other one I just opened it in the other window. So what I'm going to do is I'm going to type in docker container ls. So this is the container which is running now. Okay, so now before I exit this container from this window, I need to commit all the changes made to this container into a new image. For that, I'm going to make use of this command docker commit followed by the container name where we have installed all the necessary software or the necessary items, and this is still running. Okay, so while it is running, we are trying to create a new image. Okay, so the command is docker commit and the container name and the name of the image. Okay, and version 1. Okay, so this is the name of the image. Here I'm saying it's Raj Tech Trainer / robot framework, and this is the version 1 of this particular image based on whatever is contained in this container. Okay, so let us hit enter. Okay, now if I do docker images, okay, this is the Ubuntu image which we had pulled and we have used it as a base image, and now we have another image called Raj Tech Trainer / robot framework, and the version is version 1. In case of Ubuntu, the version is the latest version. In our case, we have created the first version of this particular image. Okay, so if I do docker history of Raj Tech Trainer / robot framework and version 1, here it says we have used the bash command. Now if I do docker inspect, now earlier we had 4 layers. Now we have the 5th layer which was added by all the installation which we have done on this particular container. Okay, so now if I quit this, clear screen. Okay, let me close the other PowerShell window. Okay, so now if I do docker images, now I have two images here. Now if I do docker run -it and the name of the new image which we have created, which is version 1 and bash. Okay, so we have created a new container based on the new image which we have created. So this particular image should contain Python robot framework as well as robot Selenium framework. So this particular container should contain now Python as well as robot. Let us see whether Python still exists on this particular image or not. Okay, Python 3.7 -v. Okay, so we still have Python on this, and let me type robot here. Okay, so a robot is also present on this container which we have created based on this particular image. Okay, so now we have created our own image. Okay, so these are the steps which we followed to create a new image. The last command was docker commit and the container name, container ID, and the name of the image. Okay, so this is what we have done. So you can create your own image based on the requirement by following the steps which we followed just now. In your case, these software which we need to install on that particular image which we are going to create may differ, but the procedure is same. Right now we have successfully created a new image. So let us see how to push this particular image to hub.docker.com. So what I have done here is I have logged on to hub.docker.com, and if I go to repositories, okay, and I have logged in as Raj Tech Trainer, and if I go to repositories, I have one image here, Raj Tech Trainer robot image, and this is the image which we are going to push it now, which is Raj Tech Trainer / robot framework and version 1. Okay, so let me exit this. Now let me clear the screen. The command is docker push Raj Tech Trainer / robot framework and version 1. Okay, now what it is doing is it is pushing the current image which we have built onto hub.docker.com. So once it is pushed successfully, we should see that under repository section. Once it is pushed successfully, we should see that under repositories section. Okay. Let me pause this video as it is pushing and it is taking a little bit of time. Once it is done successfully, I'll come back. Okay, now this command has been run successfully and it says it has pushed. Let us go back and see whether that particular image exists on hub.docker.com. Okay, so let me refresh this. Okay, now as you can see, there is a new image which got created here. Okay, so this is how we can push a particular image onto hub.docker.com. Since this is publicly available, anybody can download this particular image and use it. That is the end of this session. Thanks for watching. Please stand by for the next video on this series. In today's session, we are going to take a look at creating an image based on
Docker file. In the last session, we have seen how to create our own image by creating a container and adding all the necessary packages within the container and creating an image by committing the changes to a particular image. The same instructions or the same steps can be followed, but in this case we need to create a file called Docker file, which is a text file, and the instructions needs to be added to this particular Docker file. There are certain commands which are available which can be added to Docker file, which Docker can interpret. In this session we will see what is Docker file first, and then what are the different commands available within the Docker file. What is a Docker file? Docker can build images automatically by reading the instructions from Docker file. Instead of having all the instructions and creating it by hand, we can also add these instructions into a particular Docker file. So you don't have to remember all the instructions or commands. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. So it is nothing but a text file which contains a set of commands to build a particular image. Using Docker build, users can create automated build that executes several command line instructions in succession. That means using Docker build, we can create a new image based out of the Docker file. The important thing within the Docker file is the command or the instructions which we give so that it creates a new image. There are a set of commands which the Docker file takes. Okay, so these are some of the basic and important instructions which can be used within the Docker file to create an image. As I said, Docker file will contain a set of commands to build a new image. The first instruction which goes into Docker file is from. Here we specify the base image which is used to create the new image. In the earlier session we have seen Ubuntu was the base image which we have used. Okay, so the same instructions can be given in the Docker file by using from command. So this must be the first non-comment instruction in the Docker file. So that means you can have comments before this and after this, but this should be the first non-comment instruction. The other command which we can use is run. As we have seen in the earlier session, we used to run the commands such as apt-get install Python, apt install Python, or apt install robot framework. So run will execute a command in a shell. Okay, the next instruction which can be used in Docker file is command. So this is the default command to be executed when the container is run. Once we create an image based out of this Docker file, when we start a container, by default whatever the command specified under cmd will be run. Okay, as we have seen earlier with Ubuntu image, bash is the default command which gets executed whenever we run the container. So the same way we can also set the default command for our own image which can be executed when the container is run by using command. The next instruction is entry point. Entry point allows you to run the container as an executable. Entry point is also quite similar to a command. However, entry point allows you to run the container as an executable. In the next session, we will see what is the difference between a command and entry point within the Docker file. Label adds metadata to the image to be created. So we can add information related to the Docker image which we are creating under label, such as who has created it. The next instruction is environment. So you can set the environment variable using key value pair by using environment instruction, env. We can set an environment variable using env and it takes key value pair. The next instruction is add. What add does is it copies the files directories from the source file system of the image at path destination. So what basically add will do is it will copy the files and directories from the source to the destination provided within the image. Okay, so these are some of the basic and important instructions which can be used with Dockerfile to create an image. In the upcoming session, we will try to create an image by using Dockerfile. It is recommended to create a new image based on the Dockerfile so that we can update the Dockerfile at any time and the maintainability will be easier with Dockerfile. That is the end of this session. Thanks for watching. Please stand by for the next video. In today's session, we will take a look at the two instructions which are quite similar, but there is a difference. Those two instructions within the Dockerfile are command and entry point. What is the difference between command and entry point? Both command and entry point instruction define what command gets executed when running a container. So let us look at what command does. It sets default command with or without parameters, which will be run when the Docker container runs. So whatever the command which has been specified with the instruction command, that command gets executed whenever we run a container. Okay, if the Docker runs with a command, default command will be ignored. So that means it is possible to override the default command. For example, we have created earlier one image with Python in it. So we can either use Python as a default command, and we can also override it with a bash command. Okay. So if you have multiple command instructions, then only the last command instruction will be executed. So if you specify multiple command within the Docker file, only the last command gets executed whenever we run the Docker container. Now let us look at the entry point. Entry point is quite similar to command but runs as executable. That means the default command cannot be changed in case of entry point. Whenever we use entry point, the default command specified within the entry point is the only command which gets executed. So you cannot override this particular command. Okay. However, with the command, you can override the default command. Use entry point when you need command to be executed always. So if we have multiple commands whenever we run the container, then we should use command instead of entry point. In entry point, the Docker command and parameters cannot be overwritten. So the command as well as the parameters cannot be overwritten. Parameters will be appended. By default, if you have provided a parameter along with the command, that parameter and command is set. That means it cannot be overwritten. However, the additional parameters which are provided while running the container will get appended. Okay, we will see how this command and entry point executes and how they are different by using the image which we have created earlier using Dockerfile. Okay, so earlier we had only 3 statements here with the Dockerfile. If you want to know how we created an image out of this Dockerfile, please refer to the earlier video. One extra thing which I added here is the label. Okay, so I have added the version as latest, maintainer as Raj Tech Trainer, and the email ID. The additional command which I'm going to provide here is, first we will try to use command here, cmd, which is the instruction which goes into Dockerfile, and by default I want to run this command, Python 3.7. This command instruction is only taking the command which is Python 3.7 and there are no arguments provided. So let me go back to my PowerShell, and since this Docker file which I updated is in ddocker, we are in the same folder here. So we will try to create an image based on the updated Docker file. So in order to create the image, I'm going to make use of docker build command, and the name of the image will be the same name which I have given earlier, and the location of my docker file which is in the current location. Hit enter here, and that will build this particular image. Let me pause the video and get back to it once it has created this particular image. Okay, now it has created this particular image. Let me go and see. Let me clear the screen first. Docker images. Okay, now I have this Raj Tech Trainer / Python which was created just now, and now if I go back and run, okay, if I create a container based on this particular image now by docker run -it and Raj Tech Trainer / Python. Okay, and if I hit enter, then it goes and runs the default command which we specified. And the default command which we specified was, if you look at the docker file, it is Python 3.7. okay, by default it will run whenever we run the container. By default it will run this particular command. Okay, let me do Control D. However, it is also possible to override with a different command. Okay, so by default here I haven't provided any command. By default it will run Python 3.7 command. However, I can override it with a different command. In my case it is bash. Okay, so now we have bash shell here. Now we will try to add a parameter here. To add a parameter, we need to first have the command within the square brackets, and for the parameter I will add here /app/test.py. okay, this is the parameter which we are passing to this command. Okay, so let me save this and exit here. Let me rebuild this image. Okay, so right now it is very quick because all the additional layers are already there. Docker run -it -v, which is the bind mount which we are trying to create here. Okay, d:/docker, and we are going to map this to app folder inside the container. Okay, and the image name is Raj Tech Trainer / Python. Okay, before we run this particular command, we need to have this test.py inside the Docker folder. Okay, so what I'm going to do is I'm going to create a file here. Okay, test.py. Okay, and I'm going to have a simple print statement here. Print hello from test.py. Okay, so let me save this. Now we have this file created under our Docker folder, by using this particular command, what we are trying to do here is we are trying to map this D Docker folder and D Docker folder, which is a source folder, and it is mapped to app folder on the container whenever it runs. So that is why I had given /app/test.py. Okay, so let me run this. Now you can see that since this particular test.py is shared and this particular parameter is passed to this particular command. Now this Python command is executed by passing this file name. That is why we get the output as hello from test.py. So which is what we have written in the test.py file. Let me copy this and then paste it here. I'm going to make it as test1.py. Okay, so let me open this again. Okay, so I'm going to edit this to make it as test1.py. Now I have two files, test.py and test1.py. Okay, by default it is using Python 3.7 with this particular file name, so I can override that by making use of this command with okay. Now you can see this is hello from test1.py. So by using command we can also override the command as well as the arguments. Okay, now let us take a look at entry point. Okay, so instead of command I'm going to add entry point here. Okay, let us begin with the way we started off with command, with just the command. Okay, Python is the command which is specified to entry point. Okay, so let me save this by using docker build command. The image is created. Now let me clear the screen. Okay, let me run this command, docker run -it raj tech trainer /python. Okay, so this is the first command which we ran with the command instruction also. So so far, by providing either command or entry point with one command has got no difference at all. However, if I try to override the default command or default entry point here, which is Python 3.7 to bash, in command it will override, but however with entry point it won't override. It will still go to the Python which is the default command. Okay, so that is the major difference. Let me clear the screen. Now let me add parameter here. Comma /app/test.py. Okay, so let me save this. I have added a default parameter here which is test.py. Okay, so let me create or let me build the new image. Okay, let me clear the screen again. Now if I run this command, if I hit enter here, this is hello from test.py. Okay, so let me run this particular command. It still says hello from test.py. Okay, by using entry point neither we can override the command nor the parameter. However, this parameter, whatever we have provided, it gets appended to this particular command. Okay, so that is what we have seen here. Docker command and parameters cannot be overwritten, parameters will be appended. Get the benefit of both command and entry point, wherein command will allow us to override and entry point will have a fixed execution point. For example, if I provide command here and by default it should run, for example, help.py, okay, and the entry point will be Python. Okay, so what we are doing here is our entry point, our executable, whenever we run the container, our executable will be Python 3.7, and we can override this help.py with whatever the Python file which we create. Okay, by making use of entry point and command, we can achieve this. Let us see an example of this. Okay, since we provided a help.py under command, I'm going to create here help.py. So let me copy and paste this, make it as help.py. Okay, so let me edit this file. Within this help.py, what I have done here is I'm just printing the usage. If the user by default runs the container without providing any parameters, then it should give us this usage string. Save this. Let me go back to PowerShell and clear the screen. Okay, since we have added entry point and command within the Docker file, we need to create a new image. We need to build a new image. To build a new image, again I'm going to use docker build command. Okay, now the image is built. So let me clear the screen. So if I use docker run -it -v d:/docker and /app Raj Tech Trainer /Python. Okay, so here I'm not providing any parameter. By default it should give me the help string. Now I will provide the parameter here as app/test.py. Okay, so what this will do is this will override the default help.py. Okay, that is the use of command here. By combining command and entry point, we can also override the parameters. Okay, by just providing entry point, we will have an executable. By providing command, we can override the parameter. So now if I run test1.py, it says hello from test1.py. So by making use of these two instructions, command and entry point, we can achieve one. By default it will run only the command specified in entry point. However, we can change the parameter which we are passing, or we can override the parameter which we are passing. Okay, so this is what we have seen here so far. Okay, let us do a quick recap on command and entry point. Both command and entry point are used to run the default command whenever we create a container. By using command, we can set the default command. However, the default command can be overwritten. With entry point, we create an executable and the default command cannot be overwritten. Whatever the parameter which is provided while running the container will get appended to the the entry point. However, we can combine the features of command and entry point. By providing entry point, we can fix which command by default it will run, and by using the command instruction, we have the flexibility of providing the parameters during the runtime. I hope this is clear to you. If not, please provide the comment. I will try to answer the queries. Thanks for watching. Please stand by for the next video. In the earlier session, we have created an image without using Docker file. In this session, we will try to create an image based on Docker file. If you are new to Docker file, please watch the previous video before continuing with this video. Okay, let us create a Docker file first. So I have a Docker folder. Under this folder, I need to create a file called Docker file. And there is no extension for this Docker file. Okay, so let me edit this particular file. As we have seen from the previous session, the first statement inside the Docker file is from, and the base image which we are going to use is Ubuntu, which we have already downloaded. Okay, the image which we are trying to create here is just to run Python. Command which we are going to run is apt get update, which is the first command. Okay, and by using a run instruction, we will again install apt install Python 3.7. Okay, so we are going to create a simple image with Python in it. Okay, let me save this and let me open up a PowerShell. Okay, let me increase the font here. Okay. Okay, let me go to that particular folder. So inside this, we have created our Docker file. So to create an image based out of this Docker file, we have to use this command, which is docker build -t, and the image name is Raj Tech Trainer /Python. So this is the image name which I'm going to create, and followed by the location of the Docker file, which is dot. Since the Docker file is located on the same folder, hit enter. Now it is running those instructions which are provided in the Docker file one by one. It is using Ubuntu image since we have already downloaded, and it is running apt get update. So it is updating all the packages for Ubuntu. Okay, here the installation failed, or creating an image failed, because it is asking, do you want to continue, yes or no? While running this apt install Python command, it was asking for user input. Do you want to continue, yes or no? So in order to avoid this, because we cannot give yes or no here, so instead of that, we will add switch here, -y to skip that. So we have added -y to skip this particular user input. Okay, so let me rerun this. As you can see, it is trying to install Python now. What it says is it has successfully created a new image. Since we didn't provide any version there, so it has created a latest version of this particular image. Okay, so let me clear the screen now. So let me go to Docker images. As you can see, it has created this particular image, Raj Tech Trainer / Python image with the version latest. Okay, let me clear the screen. Now, if I do Docker run -it Raj Tech Trainer / Python. Okay, by default it runs bash command. Now if I do Python 3.7, okay, so this image contains now Python. So when I run this Python 3.7 command, so it goes to our Python command prompt, and it also displays Python 3.7.5 is installed within this particular image. Now with this, we have successfully created an image based out of Docker file. Okay, so this is a simple Docker file which contains 3 instructions. One is from instruction and 2 run instructions. Preferred way of creating an image is based on Docker file. Let me exit this. Okay, if you see, for the first time when I ran the Docker build, it took some time, but further Docker builds took very less amount of time, and this is the easiest way as well as quickest way of creating an image. That is the end of this session. Please stand by for the next video.